So really, you wanted me to restore this thing? Well, now at least I know who my friends are, don't I? Yes, that also doesn't quite fit. And that doesn't fit. Well, that really shouldn't have been so hard, should it? I quite like to use brake and clutch cleaner to clean out these variable capacitors, but you do have to go ahead and re-grease them afterwards. Of course, the only problem with using this brake and clutch cleaner is you tend to get quite high on it. Getting a bit light-headed actually. And of course, always remembering to remesh this variable capacitor. Well, as you can see, this radio is actually in probably better condition than the other one. The only problem is the cabinet is actually infested with woodworm, and with that we cannot put up with, which is such a shame. You can see the Master's Voice label there. That's in absolutely beautiful condition, really nice. Oh, and what a lovely weighted movement to the tuning control. You can really tell those big flywheels in these sets are doing the job perfectly. So I think this is actually probably going to be a donor set. Let's take a look at the chassis and see if that's in a better condition. Well, I can see we've got a fair amount of dust going on in there, but all the valves are intact. We've even got the screen covers on all the valves. Nothing's smashed. It's much better, the condition of this chassis, and it's also not covered in rust, which I think is an advantage as well. But I think before I withdraw the chassis, the next thing to do is actually to remove the dial cord, which I think we actually do from down here. Hopefully you can see what I'm pointing at. Yep, I think that should be the dial cord mechanism release now. So it looks as though the radio is designed such that we can actually withdraw the chassis and maybe leave the speakers and some of the wiring in place. It looks pretty long, so maybe we can do that. And now I'm thinking that I can probably remove the whole baseboard assembly now, along with the louvered glass front on it, so let's give that a go. Oh, quite a substantial dial lampage assembly there. That's quite impressive, isn't it? Well, apart from being a little bit dusty, it looks like our louvered glass radio dial here is in pretty perfect condition, but the problem is I can see looking at the baffle board that everything's mounted on, everything is actually full of these woodworm holes. So I think these maybe down here are the actual remains of the woodworm larvae. Now I can also see looking at the bottom of the cabinet, it's absolutely covered in dust. I've got a feeling they call that dust fass, and I think that's again where the beetles or adults have emerged from the flight holes. They push all the sawdust out and it mounts up in the corners. I'm sure they call it fass. Anyway, certainly not going to allow this into my house because there's an awful lot of wooden beams in my house. So I think what we'll do is we'll take this Bakelite, this plastic off here, and hopefully the woodworm haven't eaten their way into that. I don't think they will have done. So I think it's time to remove that louvered glass front from this woodworm infested baffle board. Hopefully without dropping it. Okay, so here's our glass work. I'm going to have to be very careful with this because some of these, well in fact all of the panels are just sat in there. There's nothing actually retained, so we'll maybe put some tape around that to stop these pieces of glass falling out and getting broken. I'm hoping we can just remove this speaker because you can't get at the nuts on the other side of the baffle board because the grill cloth is in the way. Yeah, looks like these are coming out a treat actually. Ooh, what a lovely speaker, what a whopper. That's perfect, isn't it? Absolutely perfect. Well, if you watch the beginning of this video, you can see that I went ahead and I got a replacement parts set. Now, I have to say that the chassis in the parts set radio is in much better condition than this one, in that you can see that even though I've done my best to give this a bit of a clean and a rub down, there's still quite a lot of surface rust on the radio. Now, in some ways, I'm not too concerned about the surface rust because it won't actually stop the radio from functioning. You know, it won't affect the performance even slightly. A little bit of rust here and there, and this radio is going to be stored in a dry house, I hope, for the rest of its life. So we don't need to really worry about the rust getting any worse. And if I was concerned about that rust, probably what I would do is that when I finish this, I'd probably just give it a quick spray of clear coat lacquer over the top of it, because I don't mind a little bit of rust here and there. But yeah, some of the chassis is very rusty, so some of it probably wants a bit more of a cleaning up. And what I was trying to get round to is I haven't really decided which of the radio chassis to do the restoration on. Now, the second chassis that you saw me taking out of the box a minute ago, that's certainly in much better condition. There's no rust on it, there's none of the IF transformers smashed off it like these are. Also, when I had a look inside it, they didn't seem to be have the number of burnt capacitors or the kind of internal damage that this one has on it. Now, I can also see that the pitch covering on this transformer here, it does look just a little bit melted and bubbly to me. That could mean something, or it could actually mean absolutely nothing at all. This transformer could be fine. So I haven't made the decision of which chassis we're going to do up yet. I kind of feel as though if I do up the better chassis, I will be, you know, short-changing you guys, because you've come to see this radio being powered up and got working and not the other one. So I think what I may do is I'm going to go through the exercise of trying to power this up and resurrect it, and we'll see how it goes. But if it looks as though it's really looking bad and terminal, there's no point in punishing myself with it. So what I think we'll do is we'll swap over to the other chassis, and hopefully that other chassis will work better. So I can immediately see that just looking at the tops of this, we've got some electrolytic capacitors on them. At one point I would have said that these should be changed out on site, but having changed out a few electrolytic capacitors and cut them open, I've actually found them to be in reasonably good condition recently. But no doubt if we don't change this out, we'll have problems. Now, I can definitely see that this one's got a little bit of a bulge in it, and I suspect it has vented. So certainly, even if we don't change out initially, we're going to test it before we power anything up. We've also, looks like we've got another electrolytic. So unusually, it's got a couple of quite large electrolytic capacitors in it. I think I want to screw down this very wobbly, loosey-goosey IF transformer. Don't think it's going to be at exactly the right angle, but we want to screw it back down before it totally falls off and rips the wires out. We've got some valves that we pulled out of the other set, so I think what we might do first is I'm just going to spray some switch cleaner in it, because there's no point in fighting things like switch cleaner faults, dirty switches, dirty contacts. So we'll give all them a little bit of spray with cleaner because they are dirty inside, they've not had valves in. I think we'll also go ahead and we'll spray a little bit of contact cleaner into the volume pot, although looking at that one, no, it is one of the sealed types, so I think you've really got to open them to get cleaner into them. Yeah, we can't actually, oh yeah, we might get a little bit in there. So we're going to spray some cleaner into the pots, going to spray a bit of cleaner into the wave change switch here, give it a bit of a flick round, because I don't see the point in chasing my tail with dirty switch problems. So that's the first thing that I do on any radio. I actually just go in and I just give everything a bit of a squirt. So this is the Radial gram switch. I think I mentioned this switch before, and I said that this is the gram switch, but I didn't actually explain the purpose of it. So if you had a separate record deck, you could actually use the radio here as an amplifier, because obviously it's got a fairly good amplifier valve in it, a KT61, quite a large speaker. So you could actually plug in I guess a stylus from a gramophone, and that would give you some amplification. So that was the purpose of this gram switch. So the gram switch allows you to switch between an external record player and also the radio's internal radio circuitry. So you slip to either the gramophone or the radio. Now I can see the control shaft on this potentiometer stroke on and off switch. It's actually pretty bent, so that could do with stripping apart and I don't know, trying to straighten it. I don't know if we will be able to straighten it. And it's also, yeah, I think it's stiff because it's bent internally. So that needs a bit of a dose of looking at. I think the next switch on here is the tone switch. So it doesn't have a potentiometer for the tone, it just has this selector switch. So I'm guessing that switches between various banks of capacitors. I know that some people like to complain when I put a switch cleaner into these wafer band select switches, because they're quite right that the oil does actually kind of absorb in it. It actually goes into the, I don't know, the Bakelite, into the material, it gets soaked in, and it does tend to attract dust and go a little bit dirty, but I do think it's still worth cleaning these wafer switches on the band select. And I have to say, I've never had a problem after cleaning one, but I know some people don't like to do it. Now on my first look at these two fuses, I actually speculated that one was maybe primary and one was secondary, but now I've taken a moment to look a bit more closely, I can actually see that both fuses are actually in line with both the live and the neutral from the mains power supply. So I'm guessing that although this has got a 3-pin plug in it, originally this could have been probably plugged in off something like a light fitting which wasn't polarised. A lot of people didn't have plugs in their houses back in the day, back in the 50s and things like that. So what they used to do is they used to get the power supply for the radio off something like a lamp fitting, and that would be unpolarised, so you wouldn't know which was live and neutral. So I'm guessing the reason that they've actually chosen to fuse both the live and neutral is because of that. So you can actually see that these two terminals on top of here, they're actually quite vulnerable. I really don't want to put my wrist on top of here while I'm doing some testing, so I think we'll probably put a piece of cardboard on here just to give myself a little bit of protection from these live terminals. And the other thing I can see is I've also got some kind of lengths of wire. I think I might leave the this main flex in place just to do a little bit of testing. Is it okay? Let me just have a look. Actually it's not great. We'll probably take this mains flex off, and what we'll do is I will attach a 3-core cable to it to do the testing, because although it can create some mains hum, I like to have my chassis actually earthed. Anyway, we're getting ahead of ourselves. Let's just do some testing on this transformer first. Right, that's in the megohm, so that isn't what I was expecting, so I wonder why. So either the switch is open circuit, or we've still got a bad connection on here. I think might just try and do a little bit more cleaning on these. So I think unfortunately this radio's probably been stored in a very damp shed or something like that. So there's a lot of corrosion on the parts, and that's not really a good thing. It's not really the surface corrosion that I'm worried about, and even the stuff on these contacts. What I'm worried about is things like the very fine wires inside these IF transformers, and also in the radio tuning section, because if those have been exposed to damp for a long time, they're so thin, the wires, that they tend to suffer from that green spot mould, and well, they fail, they go open circuit, which is obviously a big problem to us. See, we've got a better reading now, we've just cleaned that off. Okay, 36 ohms, that's maybe just a little on the low side, but also not definitely wrong either. So I'm going to replace our voltmeter here with our Samyo insulation resistance tester. I actually do recommend these are relatively cheap on Amazon, and they seem to work really pretty well. I've also got an Avo insulation tester, which is a lot more expensive than this one, but I find that these work quite good enough. And one of the things that I like about this is for testing capacitors, because it's got some low voltage settings. So it's got a 250 volt setting, a 500 and 1000, and especially the lower, the 250 volt setting, that can be ideal for testing capacitors. So the first thing I'm going to do is I just need to find some metal work, something which is ideally bolted to the transformer. So I think I'm going to go off this piece of metal. So I'm just going to take a link wire now, and I'm going to strap the live and the neutral going into the transformer itself. I'm going to tie them together, and then I'm going to clip to one of them the insulation tester's leads. So let's go for 500 volts first, and that's indicating 24 megohm to earth. So we have got some resistance between the transformer's internal windings, but we certainly haven't got a very low reading. Anything probably less than about, I don't know, about 5 megs I would be starting to get concerned about. Let's try it at 500 volts, because usually you do a test at twice the rated voltage of the equipment. So again, at 500 volts it's still measuring 29 megohms, and in fact let's do it at 1000 volts, which is more voltage than we need to, but we've done it then. And again at 1000 volts it's indicating, again, 31 megohms. So the next test that I'm going to do is I'm just going to look for any resistance between the primary and the secondary windings, and I'm going to do that via this valve base here. So we've got one connector here, the original one, that's still strapped across the two primary live and neutral wires going onto the transformer, and there we've got the secondary. So we've got about 50 meg, about 50 meg, about 50 meg, and about 50 meg. So again, I don't know if this transformer is good, but at the moment it's not looking electrically unsafe. That doesn't mean that there isn't a winding open circuit somewhere. There could be an open circuit winding. In fact, let's just try looking at these secondary windings while we're here. So I'm not exactly sure which winding is connected to which here, so we're just looking for a resistance reading. So that's 0.8 of an ohm. I'm guessing that 0.8 of an ohm there could be the actual filament windings, because they tend to be a bit thick and a low resistance. And then we've got one that's about 600 ohms, also got the high tension line there, which is 600 ohms. Again, that seems a little bit low to me, but could be okay. So this is the old plug that came on the radio, and it looks like it's made by Emelec, and you can tell it's an old plug because it doesn't have the insulated sleeves on the live and the neutral here. So probably a good idea to change that out, and it keeps the safety police happy. Now, I always like to play the plug game, and the plug game is, let's guess what fuse it is. Well, I've got to admit, I know it's a little bit obvious, and yeah, I'm kind of a simple person, so I'm going to go with the obvious. I think this plug will have a 13 amp fuse in it, but I don't know. Place your bets. Come on, lucky 13, lucky 13, come on. How you feeling lucky? That's what you've got to ask yourself. Oh! Well, where did that come from? No fuse at all. Wow. So I've gone ahead and I've also earthed the radio chassis. I know some people say it's not necessary or choose not to. Well, that's up to you, but I do like to make sure that the radios that I work on, if the chassis can be earthed, not all sets can, of course. AC/DC sets, you can't earth the chassis, but typically if it's got a transformer like this one, it is possible to earth it. And this is an isolating transformer in that it's got no contact between the primary and the secondary. Of course, some radios also have auto transformers. So yes, we've got an earth. I'm happy. So I think the main protection you get from earthing a radio chassis like this is that if you've got a relatively modern house, your house will have an earth leakage circuit breaker, of course, and that does mean if you've got a fault, that your earth leakage circuit breaker will detect that fault and it will disconnect the main supply. Now, I did do a little bit of testing beforehand, and I always think it is still a good idea to test this, because if you do trip the power out, you know, you might switch off the video recorder halfway through recording EastEnders and then you'll be in trouble. So that's one of the reasons I take a little bit of care before I even plug a radio in, to make sure it probably isn't going to fail on the earth leakage, because yeah, that makes me very unpopular with the wife when I cut the power off to the house. So as you can probably see, I've gone ahead and I've just made some plastic shrouds to go over the top of this fuses here, because it would be quite easy to put my hand on there while I'm working on it. And also it's got some exposed terminals at the back which are used to do the voltage tapping selection. So again, I've just put a piece of cardboard over there, which is just to stop me accidentally brushing my hand against it, because that would be very unpleasant. So I've gone ahead and I've taken out the lamp limiter here. So if you haven't got a lamp limiter for testing valve radios, you really should have one. You should go away and build one. Very simple to build, very useful. And we've got a 100-watt bulb in here, and because we haven't got a rectifier valve in, or any other valves for that matter, I'm not expecting this to really light up at all. It might give a brief flicker when we switch on, but probably not. Is that on? Okay, let's switch on now. So let's just check we've got some power on the transformer now, if I can just get my test leads under here. Okay, I've got about 240 volts on there, so hopefully we should have something on the secondary of our transformer. So this is kind of a centre tap arrangement, so I would expect us to have, I don't know, just over 300 volts on each side of the centre tap. So let's test one side first. Okay, so that side has got, I don't know, about 325 volts. So one of the things about testing these centre tap transformers, the other side of the centre tap should really be pretty much exactly the same. So let's see what that is. Okay, 325 volts as well. If you get more than just a few volts difference across the centre tap, there's something wrong. It indicates that you've maybe got a shorted turn and the transformer's failing. We're not getting that. Both readings are very close to each other. And then if we go across the pair of windings, we're going to get 600 and, I don't know, 650 volts or something. There we go, 650 volts. Let's have a look at the valve heater now. Getting a bit dirty. Okay, 4.5 volts, probably in the ballpark. So I've just realised that we haven't actually tested the supply to the valves, or in fact the lamps on the front of the radio. So I went out to the old cabinet and I've disconnected them lamps and given them a bit of a wipe over. And these had previously been cut off for some reason. Don't know why they were cut out, but somebody had cut them off. So we've got to rejoin these. I've also gone ahead and I've got the speaker out of the old cabinet as well. So we can go ahead and we can try it with a speaker on it. And we'll maybe just try giving it a buzz with my signal tracer. Usually you can hear that through an output transformer. It's always a nice little test to do. But first of all, let me just solder these dial lamps on and put some power on again and see if it works. All these bulbs look as though they've got a mirror finish on them, so I think that this particular radio set, I think it's probably got an awful lot of hours on it. So looking at these bulbs, I can see that inside them, they actually look as though they're almost filled with mercury. They've got like a mirror finish to the actual bulb surface of them. So what that means is either these bulbs have been in for a very, very long time. All these bulbs look the same, so they're probably the original bulbs. Or it could also mean that the set's been run at too high a voltage. But I'm actually guessing that this set, just by the condition of it, I think that this set has just got an awful lot of hours on it. Of course, we've got to make sure that we solder these wires the right way round, brown to brown and black to black, because if we don't get them the right way round, it'll suck all the light out of the room when we switch the radio on, won't it, if the bulbs are wired up backwards, so we've got to get that right. We could also have a bet to see if any of these bulbs actually light up. I would be kind of quite surprised if any of them do light up actually. I'm going to say, my guess is that we'll just get one bulb coming on, just one out of the 4. So place your bets now. How many lamps are going to come on? 1, 2, 3 or 4? I say 1. Well, I think we've got power on it, so it looks like none have come on. Okay, we've got 6.8 volts according to that. But none of our bulbs have lit up, so that must mean that every bulb has failed. Be nice to get one bulb lit at least, wouldn't it? It's got to be some kind of a record there, hasn't it? 4 bulbs, we had 4 chances and every bulb has gone. I wonder what period of time these bulbs finished at. So I'm guessing these are going to be 6.5 volts or something like that. 6.3, is it 6.3 or 6.5? Yeah, 6.5. So we've got 2 bulbs. Don't know what voltage that is, can't see any labels on these. That one seems a bit dimmer actually. Okay, so we've got some bulbs there. So remind me, I need to order some new bulbs. Are these Mez bulbs? Mez? I can never remember. What size are them? Somebody will leave it in the comment, I'm sure. So there's our 4 bulbs illuminated, so that's about the level of technology I can work at, which is switches and bulbs. That's me, that's the extent of my skill. And as you can see, we have 4 bulbs now lit up beautifully. Bulbs, lamps, whatever. So I think the next thing to take a look at is the smoothing capacitors, and actually this has actually got a fair amount of smoothing capacitors. It's effectively got a 3-stage CRC filter. So it's got a 3-stage filter here, and then it's actually got some additional HT smoothing in this other can at the back here. So I don't think I've ever seen a radio that's got quite so much smoothing on it. So one would assume that the amount of ripple or noise should really be very low. So looking at the condition of these capacitors, the tops of them are certainly quite cracked and they do look pretty crusty, and I can see it looks as though this one might have got a vent mark in the top of it there. So I'm not really hoping great things from these, but you never know. Let's just see what the ESR comes up as. I'd hope we could get these working or potentially just reform them. Okay, so it's saying that one is not measured, ESR is greater than 40, so effectively I think that means it's pretty open. Let's look at the other section. Okay, the other section's coming up as 26 microfarad, but again it's coming up as an ESR of greater than 40. Now I'm wondering if these will reform at all or not. I've never tried to actually do an ESR measurement before and after. Now anybody who's actually repaired a valve radio before will know that it's actually pretty pointless trying to reform capacitors, but of course there's always people that haven't, that like to go, oh, you like to reform them, you just reform them and they'll be fine. Well, okay, for all those reforming capacitor fans out there, let's go ahead and reform this. Okay, so I've had this on the power supply, and I've got to admit I turned the voltage up and it did appear to be reforming, but having spent about an hour bringing this up slowly, it isn't drawing any current, but it does appear that the capacitor has just effectively gone open circuit on both of the segments. So Yes, unsurprisingly, reforming capacitors is just generally a total waste of time. So I do seem to remember we had some other capacitors which are on the underside of here that looked as though they'd actually been on fire or smoking. Well, I don't know which those capacitors are off the top of my head, but clearly they were probably seeing quite a lot of voltage across them to get in that condition. So I think the easiest thing to do is actually just remove them from circuit. So that one there, that one looks bad. I can see it's got a burn mark in it, so that's coming out for now. And there is another capacitor here which has, well, literally it's just turned into well, I think it's a capacitor. It seems to have turned into a, well, a lump of carbon. That's all I can really describe it as, a lump of carbon. I'm sorry I can't really get you in at a good angle there, but you see this black charcoal thing here? That is actually a 0.05 AF coupling capacitor, and it's actually just been reduced to a lump of carbon. I've never seen a capacitor as bad as that. Something's seriously gone wrong there, so what we will do is I think we'll have to have that out. Now, I say it's all charcoal. I wonder if it's actually got some kind of protective jacket around it. Maybe it was to protect it from the heat of this large dog bone style resistor next to it. Now unfortunately that one looks, it's almost impossible to get at. I wonder if I can release this whole chassis rail and move it out the way. Considering this was just meant to be an initial quick power up, I'm certainly having to do quite a bit of work, aren't I? So it does say it's 0.05, it's all rusty on one end, and I don't know if that's a melted wax capacitor or if it's in some kind of jacket. I'm thinking maybe it's in some kind of jacket. So it's a 350 volt 0.05 microfarad. I don't think I've ever seen a capacitor with this construction before. I'm just going to unpeel it. Probably find after doing this it works perfectly. Almost looks like a fuse. Have you ever seen a capacitor like that before? It's a first for me. So this capacitor is not actually measuring as bad as I thought it would. It should be 0.05 microfarad, and it's actually measuring 74 nanofarad. So it's only 24 nanofarads actually too high, isn't it? So it's gone out a little bit, but it's not ridiculously out. But it's certainly a funny looking thing. Of course, just because the capacitance good doesn't mean that it's not leaky as hell. So let's actually try it on the resistance meter there. Okay, so it is leaking. This is coming up as 0.2, so it's 200k. So that's at 250 volts. So yeah, that is leaky as hell. So that probably would have. I think that's our grid coupling cap for our KT61. So that would have destroyed our KT61, our very expensive valve. It would have destroyed it in short order, I would have thought. Well, as you can probably see, I've gone ahead and I've restuffed these capacitors. I've emptied out the old gubbins from them, and I put some brand new capacitors inside them here. So this capacitor is going to go at the back in that position, and then this is actually the main smoothing capacitor. Again, you can see the new capacitors inside it, and this one is going to go here. So I've gone ahead and I've reinstalled those smoothing capacitors, and I've checked the HT, and unfortunately I found that one of the parts of the circuit for the HT didn't have any. So I did a little bit more digging, and I've actually found that there was actually another smoothing resistor here which couples one of the capacitor segments, which is C30. Now the resistor itself, you probably can't see it because it's under the chassis here, and it should be about 2.2k, but it was actually measuring open circuit, so it meant that some of the radio circuit wasn't seeing any voltage because this smoothing resistor had gone open circuit. So you can probably see I've just bodged a modern 2.2k resistor on top of it just to do a little bit of testing. If we get this radio up and running, I will go ahead and I'll tidy all this work up later. We're still very much in the resurrection stage, so we're just tacking capacitors on and resistors on just to see if we can get it to work. But interestingly enough, this resistor that was terribly charred and burnt, it was actually also located directly next to the AF grid coupling capacitor. So probably what happened was when this resistor got hot, it probably resulted in charring and damage to the grid coupling capacitor, the KT61. So it's probably a good job that we found that. So really, I think the only job that I've got to do immediately now is to put another grid coupling capacitor in to replace the one that we snipped out, put another grid coupling capacitor in, and then we can probably try the KT61 valve in, run it up and see if we can get any noise or any crackle out of this thing. Well, as you can see, I've gone ahead and I've robbed all the valves out of that other chassis, so I think there's not much more to do now. We've got the smoothing caps in place. I've replaced a few of the coupling capacitors, or basically just tacked some new ones into position, and I think really all it remains to do now is actually just put some power on, and let's see if it actually does anything. So let me just check we've got an antenna connected, which we have. So let's just go ahead and well, let's switch the power on, and well, here's for nothing. Let's see what happens. Oh, feels like this volume control knob here, the shaft is bent and it's binding up quite badly. Now, of course, the idea isn't necessarily to fully restore this radio. I was really just trying to assess the chassis, see if it was worth repairing it. Oh, we've got some hiss. Okay, so we certainly appear to have some long wave action there. Can we tune anything in?
Yeah, do you know what I mean? That was a good day.
And his front row, my God, was at its will.
Barty's Auntie Tracy still hasn't got that kidney transplant. Tony, a shielding.
Inside.
Okay, so we've got some long wave action, that's a good sign. Have we got anything on medium wave?
Large metal doors, gates, yeah? They were banging on them. Next thing you know, they were open. Now those doors open outwards. So the only way those doors could have been opened is if somebody inside had opened them. And of course, a lot of fans ran in.
Well, considering the state of this radio, it does sound really great. It's certainly very loud.
Somebody inside the ground must have opened the gates to let them in.
I mean, we don't know how they got in, is the short answer from that context. But regardless of how it happened, is it acceptable that it happened?
Seems like the tone switch does work.
Well, I didn't see any fans doing their best.
I'll say. Coming 8, 10, you can send us an email. sundaysessionts@gmail.com.
His little face at the little round window.
Yeah, with the rain.
I'm just waving just as it takes off.
Wow, I bet when this speaker is installed in the cabinet, I bet this set sounds absolutely wonderful.
It was the best of times. It was the worst of times. It was the season of light. It was the season of darkness. It was the spring of hope. It was the winter of sadness. It was the year 1775. In France, there was a king and a queen. And in England, there was a king and a queen. They believed that nothing would ever change. But in France, things were bad and getting worse. The people were poor, hungry, and unhappy. The king made paper money and spent it, and the people had nothing to eat. Behind closed doors in the homes of the people, voices spoke in whispers against the king and his noblemen. They were only whispers, but they were the angry whispers of desperate people.